Good day everyone. So we have a laptop to fix. We have this laptop. It's an HP 250 G5 that came in for repair. The laptop is coming from another computer repair shop. So they said the laptop is coming on with no display. So let's see what this laptop is doing. We don't have a battery, so shall use the power supply, which is set on 19.6 volts, 3.2 amps. Power supply plugged. I just see 197 is going back to zero. Huh? We have a flicking current. Huh? 196.0. We don't have light here. Neither this side. We must have some lights here, and there's nothing. So I would say this job was misdiagnosed. This is not like coming on with no picture. Here we have some kind of no power issue, a dead motherboard. So all the screws are missing. Let's see if we can get inside this. Maybe we can, maybe we can't, but let's see. Let's try to get inside this. The back cover is out. That's the laptop inside. So here we have the charging port, heatsink, RAM. We do have the BIOS battery. I always love to start with the basics. Let's short pins on the BIOS battery. Let's plug back the BIOS battery. Let's try one more time. Power supply plugged. So let's check some voltages. Let's check what do we have here. What voltage do we have? Because if under normal circumstances, on HP is very easy. Or here next to the charging port, we must have an LED here, and that LED is missing. And still the current is flashing like 190, 196 going to 0, 196 going to 0. So on the charging port, we have 19 volts. I can't see those MOSFETs in serial mode, the input MOSFETs. So if here we have 19 volts, it means that the charging port is good. What is the next step? So the next step is to check on the power on button connector here. Let's check on the power on button connector here. We must have a 3.3, second pin 0, third pin 0, fourth pin 0. But on the charging port, we have 19 volts. So the 3.3 is absent. I don't know whether those MOSFETs, you know, the gatekeepers, the input MOSFETs, whether they are doing the role which they are supposed to do, like passing the 19. I'm not sure about that. but we'll see. We'll see about it. Let's check out the heatsink. And on this motherboard, I can't see like water damage or any missing component or blown up components. Everything seems to be fine. So what you can do is to check out the motherboard and do some further checkings. Because I'm sure there must be a reason why there's no light on the charging port. But we're about to see the reason why. So even the other side looks fine. Huh? But I need an insulator. We can use this. We can use this envelope just to insulate, to avoid bad things on this motherboard. So here we have the bigger MOSFET, small MOSFET, and the current sensor. Here we have 19. On the output, we have 0.11 volts. So the first MOSFET is not passing the 19 volts. Huh? And why? What? Yeah. Alright, okay, I get it. So this 19 volts here on this resistor, this is the VCC in on the BQ chip. Because here we have a BQ chip. Let's go on a microscope. So the motherboard is out. So what I want to do, what we have discovered here we have the input section. You know those gatekeepers, first MOSFET, a bigger one, smaller one, and the current sensor. So the problem, the first MOSFET is not passing the 19 volts. And I explained to you 3 major reasons why something like this can happen. Either the second MOSFET is shorted to ground, or we have a faulty BQ chip, or we have a short to ground on any of the power supplies. That can be the cause why this MOSFET is not driving the 19 volts into the motherboard. So let's go under microscope and do some checkings. Let's have some checkings here. What's going on? That's the input section. We have PQB1 and the PQB2. Those are our N-channel MOSFETs. So I'll put on volts. Let's check those MOSFETs. We have an inductor here, and it's 19. Here we have 19.6. Okay, 19. So meaning to say this is the drain of the MOSFET. On the source side here we have 0.12. On the gate we have nothing on the gate. This is not supposed to happen because this is an N-channel MOSFET. Sorry. What MOSFET is this one? Let's check what kind of MOSFET we have here. whether it's an N channel or a P channel MOSFET. So 6426, yeah, that's an N channel MOSFET. So N channel MOSFET on the gate, we must have above 18-19 volts. Between 19 to 25 volts on the gate, and we have nothing. On the drain we have 19. On the gate, on the source, that means on the current sensor we have nothing. Here we have the BQ chip, and this is BQ 25A. Yes, 25A. What you can check on this BQ chip, we need to check few things. We need to check few things. We can check the V in. Here on this resistor, you can see a big power rail which is going to the chip. This must be the V in. And we have 19. And pin number 1, 2. Pin number 6, that's the AC detector pin, 2 point something volts. 2.65 and is present. And we have a linear regulator output, if I do remember, 5, 10, 15, pin number 16. Must have 6 volts, and 6 volts is present. So, to my understanding, the condition to conclude that this is a working BQ chip, we have all the voltages. We have 6 volts is present, 2.65 and the V in. So my problem is not here. Let's disconnect the charger. Diode mode. Let's go on the current, let's go back on the input section. The power is coming here. The output of the second MOSFET to ground. So here we have a short. Here we have a short. Why? Because the current sensor, you can see the beep is beeping to ground. We have this beep. So our problem here, is we have a short to ground. So how are we going to find the short? It's very simple. We have to come with some amps there. Let's go down with voltage, 6 volts, 3.2 amps. I'm sure we have a shorted component on this one, and we have to use the thermal camera to find the short. So I've lowered the voltage. You can lower it again. 3.6 volts and then 3.2 amps. I'll go on the current sensor. You see it's taking 2.7 amps. Now let's spot what is getting hot. What is that? Huh? What is taking that power? What is here? Let's go on a microscope. I think I just seen something which is heating up. Something here. Alcohol. Let's spot our problem. What is our problem here? Huh? Let's raise the current. .8. Is it a capacitor, boss? Here, this is a switching power supply. We have a switching power supply here with the two capacitors, ceramic capacitors, and 2 MOSFETs. So either the problem is emanating from one of those MOSFETs or on the capacitor. Okay. Okay. Here I'm confused. But let's try to eliminate things. Let's start to eliminate things here. Was either short, 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 short. So between those 2 MOSFETs and 2 capacitors, we have an issue, but it's very easy. It's very easy. We can start to eliminate things here. We can do that. I disconnected those capacitors. So let's check the capacitors. So the capacitors are fine. This time we have a fault MOSFET. And here, this looks like a channel P MOSFET. Let's disconnect this MOSFET. The MOSFET is out. Now let's check again. Let's check the MOSFET by itself. So the MOSFET is gone. We found our problem. Let's look for the replacement. So yeah, I found the replacement. Let's check. This is a faulty MOSFET. We need another one. Another N-channel MOSFET. Our replacement. So let's replace this MOSFET. The MOSFET, so that everything is now in place. Where is my thermal page? I always miss my thermal page. Let's cool. We can cool this motherboard. You know, this time was a MOSFET, huh? Not every time when you have a short, it's a capacitor. This was a MOSFET this time. So yeah, what I did, I just took this MOSFET from this donor board for space, and now we must have a working motherboard. Now we must have a working motherboard. I don't expect multiple faults on this motherboard. So let me put all the connectors together. Let's see now. Plug in the power supply. And you still have nothing. How is that possible? We still have nothing on the power supply. No, we have light. You see? The probes were not properly inserted. We have light and it's taking 10 milliamps. Let's try to power on the laptop. On, and it's taking 300 something, 403. We reset the BIOS, so we have to be patient here to have something on the screen. and it's working. It's working. Please enter. So that was a shorted MOSFET on a switching power supply. And if I can see, let me see. Was this motherboard? I was trying to load Windows. The motherboard is like this. And what was shorted is this MOSFET, which I believe is the can be the 3.3 volts power supply, because next year we have a BIOS chip. So if you have this laptop and there's some kind of jumping current, that's a sign of the power supply. My variable power supply was trying to speak to me that something is wrong here, but I did not listen. But if you pay attention to the power supply, it's communicating. Here we have a problem, and the laptop is working. It's loading Windows, and the laptop is on. The touchpad is working. Keyboard is responding. So everything seems to be fine here. So that's how you can fix a dead laptop motherboard. Pay attention to what the current is doing, especially on a variable power supply. Was going to 196 to 0, 196 to 0. It was trying to communicate that here we have a short to ground on the main 19 volts power line. So yeah, that was the repair. I'll close up the laptop, but at least you manage to see how we are fixing laptops like dead motherboards. In most cases, we are finding shorted ceramic capacitors to ground. Here was a MOSFET. So like, subscribe, don't forget to turn on the notification bell for future updates. Also share our videos to beloved friends and relatives. See you on the next one. Bye.